Morning, class. All right, we're on to log functions, which is 4.2 in your notes. And we're going to talk about how to evaluate a log, how to rewrite a log, how to do operations with logs, and how that all works. So make sure you have your notes out, and let's go. So we're going to change log to exponential and vice versa, is what this means. After that, we're going to evaluate logs. We're going to actually find answers. We're going to do basic properties with logs. We are going to graph them, talk about domain and range, and the difference between a common log and a natural log, which are just buttons on your calculator. Okay, the first step is, let's go this way. How do you actually write a log? So when we have log base b, the base here is the same as the base when you have a number to an exponent, all right? Of x, x is the answer, like what b to the y would actually equal. And then it says log base b of x equals y, because logs find exponents. That is their job. All right, so when we go here, we have 7 is my base. The exponent is 3, so 7 cubed equals x is what this means. Okay, pause and do your 2. You should have had b squared equals 25, and 4 to the y equals 26. See how this one's hard to solve? That's why we use logs actually, to find exponents when they are variables. Okay, now we got to go backwards. How do we rewrite this? So we start off with log. Okay, the base, well, the base is 2, of the answer equals the exponent. Okay, pause and do yours. So you should have had log base b of 27 equals 3, and then you should have had log base e of 33 equals y. This here is known as a natural log. You will never see it written log base e. It will always be the ln of 33 equals y. You need to understand that that means base e. The other one they have is the base 10, is known as just log. So on your calculator, when you see log with no base underneath it, it means base 10. Evaluate. So we evaluate means the first thing we do is we set this thing equal to x. We rewrite it if we can here. So 10 to the x equals 100. Get like bases if possible. The bases are the same, then the exponents are equal. Okay, pause and do yours. Should have set it equal to x. So 5 to the x equals 1 over 125. That means 5 to the x equals 1 over, I hope you know 125 is 5 cubed, right? Then we need to bring him to the numerator so we can get the bases identical. So 5 to the x equals 5 to the negative third. So x equals negative 3. Next one, a little bit different, not much. Set it equal to x again. You would have had 36 to the x power equals 6. I have to have like bases. We can get 36 to 6 squared of x equals 6, and that's actually to the first. Now your 2x equals 1, so x equals 1/2. Should have been your answer. And the last one, set equal to x again. So let's just go 3 to the x equals 3. And I'm going to put this here into fractional exponents right away. 1/7, so x equals 1/7. Remember, exponent on here is 1, that's your numerator. Your index is your denominator. Basic rules of log. When you have base and the b here match, it always equals 1, doesn't matter what it is. Makes sense because b to the first equals b. When you have 1 here, the answer is 0, because no matter what the base is, anything to the 0 power is 1. This here, it's going to cancel. So when the base is matches, it cancels, so you get just the exponent, which later on when you learn multiplication property makes sense because this comes in front and this is 1. And it works in vice versa too. We can have b with the log of b as long as these bases are the same. It's an identity and they cancel and you get x. All right, so for instance, log base 5 of 5, that is my 1, my first identity. Here, log base 3 of 3 is 1, but then I'm taking that times 8. Anything with a 1 here is always 0. 15 to the 0 equals 1. Here, they cancel and you're left with 10. Here, you have 0 times anything is 0. Here they also cancel, and your answer is 7. Okay, pause and do yours. All right. You should have gotten 1, -5, 0, 0. This one took a little bit of work. This one was easy. It was the 3. You had to do this. Log base 2, and remember that 8 is 2 cubed. Then it cancels to give you the 3. Nice job. All right, now we're going to graph these things, and I'm hoping you remember a couple of things. So we're going to do -2 to 2, just a simple graph. This is going to be a parent. Now, when we type this in, and we got 3 to the -2nd, which is really 1 over 3 squared, which is 1/9. I'm okay if you can go from here to here. I'm kind of hoping you can do so. So when you do the -1, so that's 3 to the -1st, putting that into the denominator is 1 over 3. Anything to the 0 power is 1. Then you just have 3 to the 1st and 3 squared. Whoops, that should have been a 3, and 9. Okay, graph those in. So -2 is 1/9, -1 is 1/3, 0 is 1, 1 is 3, and 2 is 9. Okay, when you graph this in, if you notice, it will get as close to 0 as it can possibly get, but will never equal 0, because no matter what you plug this into, it'll be 1 over 3 to some power. So now we have this asymptote, which is y equals 0, or the x-axis. So your domain is, what can x be? And the answer is anything -infinity to +infinity. Range, okay, where does my y start to have a value? And the asymptote is, 0 to +infinity. Asymptote, y equals 0. Or you could put the x-axis. Both of those are correct. They mean the same thing. Okay, now we want to move these things. Oh, actually, I'm sorry, I lied. All right, now we want to do this. Log 3 of x. I want to do a log base 3. Okay, I know that I need to get to like -2, but this time the exponents, like we rewrite this, it's 3 to what power equals x. So I need 3 to the -2nd, 3 to the -1st, 3 to the 0, 3 to the 1st, and 3 squared. That's what we're going to type in. So when I put in 3 to the -2nd here, remember your rules, 3 to the -2, this cancels. My answer is -2, all right, which is 1/9. Well, this is technically 1/3. We're going to get -1. We're going to get the exponents as our answers. So when we go 3 to the 0, that's really 1. We're going to get 0. 3 to the 1st is 3, and we're going to get 1. 3 squared is 9, and we're going to get 2. All right, I'm hoping you notice that when you graph these, they're actually the inverses. Look at here. This point here is -2, 1/9. Well, remember, the inverse is when you flip them. So what's our, change your spots, 1/9, comma, -2. Well, 1/9, -2 was the first point we had. The next one, this one was 1/3, -1. So we had -1, 1/3. When we flip it, it's 1/3, -1. And we can do this to all of our points. 0, 1 is 1, 0. 1, 3 is 3, 1. And 9, 2. Okay, this is my new graph, or my log. Whoops, I went past my thing. All right, now if you look, if you do the y equals x line, we can see that it's symmetrical, because remember, y equals x. If it reflects over that, it's symmetrical. It goes this way and this way. Now, let's look at what we actually have. Domain is, what can x be? Well, x starts at 0 to infinity, because that's where my asymptote is. And you look, that was my range above. My range is anything, okay? It can be -infinity to infinity. Y can equal any value. That was my domain above. See how they flip spots? Asymptote is, well, this one was y equals 0. Our new one is x equals 0, or the y-axis. They're exactly opposite. So they're reflections. So if you know one, you can immediately graph the other. You do not need to do your tables. So let's go here. We want to graph both of these. Okay, pause and try yours. Okay, you should have done -2, -1, 0, 1, 2. You would have gotten 1/16, 1/4, 1, 4, and 16. So you would have been 1/16, 1/4, 1, 4, and 16. Okay, and then again, our asymptote would have been the x-axis, or y = 0. So our asymptote is here. Now, if we flip these numbers around, so this guy flipped is now 1/16 -2. This is now 1/4 -1. This is now 1, 0. This is now 4, 1. And this is now 16, 2. We just switched the x's and the y's. So I get mine over the y = x line. I hope you did well. Okay, your exponential, your domain was -infinity to infinity. That's terrible infinity sign, which means that is the range of your y. -infinity to infinity. Remember they flipped around? The range of your exponential, what can y be, was from 0 to infinity. Well, now it's from 0 to infinity on the x, because we switched the axis of symmetry, or not the asymptotes. This in here is y = 0, and this one is x = 0. Okay, let's continue on. Now I want to move this. I gave you the parent graph. This is log base 3. We just graphed it above. I want to move it x - 2. So that means it moves left or right. Remember that? Now, if it's negative, that means it's going to move right 2. So I'm going to take this whole graph and go right 2. Well, the first thing you should move is your asymptote. Your asymptote is at 0, but now it is at 2. So you draw in your asymptote. And now you look here. We've got 2 is right here. We have 1/4 at here. We have 1, 0, so it's now 3, 0. We had 3, 1. So now I need to move 3 over. 1, 2, 3 over, up 1. Add 2 to 3, and then we had 9, 2, so that's going to be at 11, 2. Everybody moved over 2. Okay, drawing your graph. Oops, I missed my dots. Moves the asymptote 3 to the right. That's wrong. This should be move the asymptote 2 to the right. So fix your mistake on your notes, please. Okay, next part. Your turn. Pause and go. Yours is going to move the graph 5 to the left. So you're going to move your asymptote to x = -5. Okay, you would have started at 0, 1 and moved over 5. 1, 2, 3, 4, 5. Now we know at 5th we would be here. And 1/25th we would have been here. So 5, 1 would have been my other point, or 4, 1, sorry, would have been my other point. So now we're going to go 4 away. 1, 2, 3, 4. Did I do right? 1, 2, 3, 4. There it is. And then the other one was at 16, 2. So let's go backwards 5. It's going to put us at 11, 2. And draw in your graph. All I did was subtract 5. I moved every point 5 to the left, because this would have been your original. Probably should have drawn that in for you. Here's your parent. We would have had a point here. We would have had a point at 4, 1 and a point at 16, 2. And then you would have had 1/4 here and 1/16 here. That is your original. And I just took every point and moved 5 to the left. All right, I hope you did a good job. Let's go here. Okay, base 10 is what's on your calculator when you see the log button. So you have a button that says log. That means log base 10. All right, it's known as a common log. It follows the same rules as everybody else. So if there's a 1 and 0, it's 10, it's to the first because it means 10 to the first is 10. There's a 10 here and a 10 here, that's going to cancel. The same here, those are both 10s and they cancel. The rules are identical. You just have to remember that you cannot actually see the 10. So when you're typing this into the calculator, it says the percentage adult boys at X years old. So we know X is age. Okay, we have f of x equals 29 plus 8.8 log of x plus 1. Now, x represents the boy's age from 5 to 15. F of x represents the percentage of his adult height. Approximate the percentage when the boy is at 10 years old. So we're trying to find f of 10. So what percentage has his height has he hit? You just literally type this in the calculator. Make sure you use your log button. We're putting a 10 in here, so we're at 11. You type that in and you should get your answer. Let's see if I can find mine. I got 79.82%. So at 10 years of age, a young boy has hit 79, whoops, said it and wrote it wrong. Don't you hate it when that happens? He's going to be 79.82% of his full height. The other one you have on your calculator is base E. Okay, base E is the LN button. So you'll see LN, and then usually it's a second key or something to get to the E. All right, log E means natural log of X, so you need to remember that. Follows the same rules again, because a natural log, so anything to the 0 power is 1. This really means E down here, so the E's cancel, giving us 1. This really means E canceling, giving us the X, and this also means E canceling, giving us the X. Identical rules, just with base E. So here we go. We have 70 to 49. Temperatures in closed vehicles climbs 43 degrees in the first hour, which is quite a bit. Models the temperature increase f of x in degrees Fahrenheit after x minutes. Use the function to find the nearest degree after 30 minutes. So they want us to find f of 30. So we do 13.4 times the natural log of 30 minus 11.6. You literally type it into your calculator like that. 13.4. Some of you may have to hit the time sign. The natural log of 30, don't forget to end the parenthesis, minus 11.6. And you should get 33.98 degrees. Okay, I hope you've done well. And good luck on your homework.